Welcome to my class Physics Untold. Here I am representing a question from Pathfinder for Olympiad and JEE Advanced, and this is from Newton's laws of motion. This is MCQ number 3 from the book Pathfinder for Olympiad and JEE Advanced. A rope of length L placed straight on a frictionless horizontal floor is pulled horizontally by a force F from one of its ends. Tension force T developed in the rope at a distance x from the rear end varies with x as shown in the graph. This graph is describing the tension versus displacement from the rear end is plotted in this graph. What we can certainly conclude about the density of the rope. Our first option is it is uniform. Second option is it decreases with the distance x from the rear end. Third option is it increases with the distance x from the rear end. And third option is maximum in the middle and decreases towards the ends. So this is our question, and this is the physical situation, what is described in our question, and this is the graph for the corresponding question. So our concept behind this question is, the concept is the tension is proportional to the mass it has to carry. Therefore, first of all, let us describe what will be happening for a uniform rod. If this portion is indicating a uniform rod, and if you take a small slab from the a portion from this uniform rod from the rear end, and this is the front end from the forces applying, let the distance of the segment is equal to x, and there will be a tension developed at this segment due to this force which is applied at the front end, and this tension is generated from the rear end at a distance x from the rear end. Let the magnitude or value of this tension is equal to T. Now the mass of this portion is proportional to distance, because if it is uniform, therefore mass will increase with the distance. As the distance increases, therefore mass increases. Therefore we can say T is proportional to Kx, and this relation can be described by a graphical way in this method. This is our T axis or tension axis, and this is our displacement axis x or distance axis. So if we plot a graph between these two parameters T and x, we can find the linearity, whereas we're seeing that here T is directly proportional to Kx, or T is linearly proportional to x, or therefore its graph must be a straight line, and this straight line is indicating the graphical representation between the T versus x. And what will happen for a non-uniform rod? For a non-uniform rod, let the mass of this portion is equal to mx, and because this mass is a function of this distance x, from this portion we can say T is proportional to mx, and if we differentiate this equation, the above with this equation, then we'll get T dot is always proportional to mx, and this T dot is always a positive quantity. As m increases along the rod, it is the slope of the graph, because we are differentiating T with respect to x, or that is this is nothing but dt with respect to dx, or we can say T dot is proportional to mx. If we further differentiate this equation, then we'll get T double dot, or double derivative of T double dot T is again proportional to mx double dot, and this is a negative quantity for the given graph. So let us take a non-uniform rod which is varying linearly. Then for this non-uniform rod, if we cut a small segment, if we take a segment up to this portion, and let this distance is equal to x, and for this distance, this mx dot is greater than 0, because of, for this portion, there is a small portion dm. Now this dm is a positive quantity because mass cannot be negative, and also the x, whatever may be the variation or shape of the rod, the distance must be this distance is always positive, it cannot be negative. Therefore, we can say mx dot equal to dm with respect to dx is a positive quantity, or mass is increasing with x, or mx dot is greater than 0. Now, if we now indicate this portion d as by dm1, and if we take another portion of mass dm2, then if we find out the of increasing rate of increment, then we'll get the rate of mass increase is reducing, because this, if the total length is decreasing in this portion, if total length is decreasing from rear end, then we can say the mass of this is dm2 is mass of this dm2 is less than mass of this dm1. So the rate of mass increase is reducing, or it is decreasing. Therefore, we can say mx double dot, which must be equal to m dm2 with respect to dx minus dm1 with respect to dx divided by dx, which must be less than 0, because dm2 with respect to dx is less than dm1 with respect to dx. Therefore, the numerator of this equation is a negative quantity, and dx is a positive quantity. Therefore, negative divided by positive must gives us a negative quantity. Therefore, we can say this mx double dot, or dm2 with respect to dx minus dm1 with respect to dx divided by dx is less than 0. Or among these four options, we can say that our correct conclusion is it decreases with distance x from rear end. Or because of this, now in our examples, in our assumptions, we are taking non-uniform rod, but this rod is uniform. But for a uniform rod, this is the identical situation. This identical situation will happen when only the density is decreasing from this rear end to the towards the forward end. Therefore, we can conclude the correct option is it decreases with the distance x from the rear end, which is a. Thanks for watching this video. Like, subscribe and share for more videos like this. Thank you.